Good morning. My name is Anna Patricia Amo, and I will be explaining the first sample problem for nuclear power plant. Number 1. A nuclear power plant that uses uranium-235 as fuel has a useful power output of 21 megawatts and an efficiency of 38%. In the fission of one uranium-235 nucleus, 3.4 times 10 to the negative 11 joules of energy is released. So we have to determine the mass of fuel used per year. Okay, so before we start any question, we should always write our given. So our given here is first our uranium-235. So 235 is our mass of one nucleus. That is the mass of one nucleus. So the atomic mass units for that is the letter U. And then we have our output, our power output of 21 megawatts. So P out is equal to 21 megawatts, and then our efficiency of 38%. Then we also have our 3.4 times 10 to the negative 11 joules of energy. So that is not our power output because our unit here for the 3.4 times 10 to the negative 11 is in joules. So we have to determine our required is to find the mass used per year. So it's said per year, so that means we are given a time of 1 year. Okay, so before we go and find the mass of the fuel used per year, let's look at this example here below, the drawing. So on the left side, I have a small nucleus, and that nucleus releases 3 joules of energy when it fissions, and it also has a mass of 2U. So let's look at the one on the right. So the bigger one on the right releases a total energy of 24 joules per year. So the first thing that we need to do is find the number of nuclei that is present. So in order to find that, we divide our total energy of 24 joules per year by our 3 joules. 24 joules divided by 3 joules, that means we have 8 nuclei. So once we find the total number of nuclei, we times that or we multiply that to the mass of one nucleus. So our total mass would be 8 times 2U. Our total mass would be 16U. So that would be the same process that we will be using when we solve this problem. However, this problem will be more complex because we have our power and we are also given efficiency. So recap, the steps that we are going to do is to first find the number of nucleus and then times the the mass of one nucleus to find our total mass used per year. Next slide, please. Okay, so in order to find our total nucleus, the formula that we would be using is energy total in is equal to the total number of nucleus times our energy in. So our energy in, that is our 3.4 times 10 to the negative 11 joules of energy. So we don't have our total number of nucleus, and we also don't have our E total in. So in order to find that, we have to use the formula of P in is equal to E total in over time. So we have our time, which is 1 year, but we will be converting to seconds. So we don't have our power in. However, we have our efficiency and we have our power output of 21 megawatts. So in order to find that, we will be using the formula here on the right. I forgot to draw a line underneath here. So our efficiency is equal to our power out over power in. So our efficiency is 38% is equal to 21 times 10 to the power of 6 since it's megawatts over our P in. Calculate that and you get your P in as 55,263,157.89 watts. Okay, so now that you have your P in, you substitute it back here. So your Pn here, you substitute your Pn, and then your time is 1 year, which has 365 days, times your 3,600 times 24 hours times 3,600 seconds, you get 31,536,000 seconds. So you calculate that and you will get your E total in as 1.743 times 10 to the power 15 joules. So now that we got our E total in, we can find our total number of nucleus. So substitute our E total into the first equation that we had just now. So 1.743 times 10 to the power 15 is equal to our total number of nucleus times 3.4 times 10 to the negative 11 joules, which is our energy in. So to find our total nucleus, we divide your E total in by your E in, and you get 5.126 times 10 to the 25. So now that we got our total number of nucleus, we can use the formula. The mass total is equal to the mass of one nucleus times our total number of nucleus. So the mass of one nucleus, as I said earlier, is our 235. That's the U235 times your total number of nucleus, which is 5.126 times 10 to the 25. So our total mass is 1.205 times 10 to the 28. So that will be all for question number 1. Thank you.
So next is the problem number 2. So before I start, let me introduce myself, and my name is Kyle Ian S. Dalida, and I will solve this problem number 2. So number 2 is a 600 megawatts PWR nuclear plant uses 4% enriched uranium fuel as a thermal efficiency of 36%. The burn up allowed of the fissionable portion of the fuel is 20%. Calculate how many metric tons of natural uranium is placed in the reactor vessel for 1 year continuous operation. So first, ilista muna natin yung given, which is the yung QA, yung power niya, which is 600 megawatts. So the percentage ng enriched uranium natin is per percent. The thermal efficiency is 36%, and the percentage of fissionable portion of fuel is 20%. So the required is the mass of natural uranium. So paano ba natin siya isosolve? So first, solve natin siya using the thermal efficiency. So thermal efficiency is equals to QA over mass of fuel times the QH. So 0.36 equals 600,000 megawatt times 8,760 hour per year over MF times 23,000 kilowatt hour over gram of uranium. So upon solving, nang makukuha natin na mass ng fuel is 634,782.61 grams of uranium per year. So next, in solving the mass of natural uranium, gagamitin natin is yung mass ng fuel divided by the percentage of uranium tapos yung percentage fissionable. Kaya 634,782.61 gram of uranium per year divided by 0.04 times 0.20 gram of uranium over gram of natural uranium, ang makukuha natin is 79,347,826.09 gram of natural uranium per year. So kung i-convert natin siya sa sa metric tons, then ang makukuha natin is 79.35 metric tons per year. So, in conclusion, ang kailangan daw natin na natural uranium para sa ating reactor vessel for continuous operation sa isang taon is 79.35 35 metric tons.